Welcome back, everyone. So in part 2 here, we're going to start to produce a linear graph. Now, let's have a quick check of our theory. We expected that the period, our dependent variable, depended on the square root of length. Now that's not a linear function if there's a square root involved. So what I'll do to remove that square root is square both sides of this equation. So t squared on the left, 2 times pi squared is 4 pi squared, and squaring this removes the root sign, so it's L over G. Now I'll leave the variable L by itself and I'll collect the constant gravity underneath the 4 pi squared. All of these are the constants. Now that looks a little bit like a straight line equation. If I have t squared as my y variable, I should have all of these constants together to act as the value of gradient. I'm using the letter B to represent gradient. And then my x variable, length, would be here. Notice that there's no addition of an extra number. That means my y-intercept, c, should be 0. And that's what I've said down here. The gradient is 4 pi squared over g. Now let's start by getting t squared and L ready to plot. So when it comes to linearizing the data, I like to separate out a little table here off to the side, separate to where my raw and processed data was. It helps when I'm doing my report that I can bring these tables in separate parts of my report, not all as one giant table. So my x values were the raw lengths. That's these numbers over here. I could literally copy those values, come across to here, and then paste the values in place. When it comes to t squared, I'll need a calculation. The value of time was stored here, and then to square we use the up, that's the caret symbol, it's like an upside down V with the 2. And there's our time squared. Once again, Control C to copy, highlight the rest of where you want and paste that formula in place. Now, I think I'm going to plot that straight away. So I highlight the 2 sets of numbers, x in the left, y values on the right, insert a scatter chart. Now there'll be a fair bit to do to improve this, but already I can see that that looks like a reasonably good straight line. So that makes me happy. A little bit of cosmetics here. This was the pendulum experiment. So we'll give it a title. Add in some axis titles. The vertical axis was the period squared, and the units would be seconds squared. Now if I click here, highlight just the 2 from the Home tab, I can make that a superscript. So it looks like a proper squared. Down here we had the length of the pendulum, measured in meters, nice and straightforward. I do not like the dots that Excel creates, so I'm going to format those before we go much further, and I will change the marker to be a nice X. So far so good. I could add a trend line at this stage if I wanted to. Come down here to the trend line, go across to the options. I'll display the equation and the coefficient of determination, and I might just make that trend line a solid line instead of a dashed line. I might make it a little bit thinner. There still seems to be dots there. That's interesting. Now, starting to look all right. I'll move that a little bit out of the way, increase the size so it's easy to read, and put a little bit of light blue background colour to make it stand out. So that's good. That's probably enough for this installment. I'll be back next time to talk about error bars.